All right, you guys, let's get started. We got our energy modeling workshop on residential compliance, and we're here at Humboldt State University. Okay, that was my introduction. Now we'll be real. Cannot minimize, but I can share my screen. It works. Okay. So I gave you guys some attachments in the email, and the residential compliance manual is the first attachment that I wanted to go over with y'all. So this is a really important document for going through the California building standards for compliance. Energy modeling in the software that I'm going to be teaching you guys in for Energy Pro and CBECC-RES. It's all about California compliance for the energy code. And there's the Title 24 standards document, which goes and outlines absolutely every standard and also all the exemptions for the building code. But then the residential compliance manual is a 500-page document that goes over really good examples of every component within the energy modeling, the energy standards, basically. So in this document, there's sections that go over the fenestrations, the HVAC, the domestic hot water, additions, and new construction. So I wanted to go through and navigate with you guys through this document. So in the beginning sections, it goes and talks about what's new in these standards for the 2016 building code. There's a new building code every 3 years. So the 2019 code is coming out probably in the middle of 2019, and it might start being enforced in the beginning of 2020. So for this building code for 2016, the beginning of this residential compliance manual goes through any mandatory requirements for the building code that's basically an update or different from the previous cycle. And then it breaks down prescriptive compliance versus performance compliance. So the differences between those are basically when you're submitting to the building department and you have a home, you have everything that you need to build, but you need to have your energy documents approved by somebody who understands the building code for the energy portion. So one way to do this is to go through prescriptive compliance, and that's where you go through basically a list broken down to your different climate zones. So it goes 1 through 16 climate zones, and I actually have the list. I'll just show you really quick what it looks like. So it's prescriptive package A, and Energy Code ACE online has free resources for all the energy modeling components and how to break down the energy code. So if you wanted to go and find more resources, they have really great videos, they have free lessons, and basically the whole building standards is on their website with an easy to navigate little system that they have. So they put together this document, and this is basically showing climate zone 1 and climate zone 16. And this is what a prescriptive compliance form would look like. This is something that an energy modeler can go through, or a builder even. You don't really need any type of certification to go through this process, but you would look at your insulation, for example. And let's say that you have a wall that you want to figure out how much insulation you need in that wall to comply with the building code. You look at your above grade wall, and we'll say it's framed, and then you go to your climate zone, and in climate zone 1, for example, it tells you need a U value of 0.051, and that's your minimum insulation value. So if we wanted to convert that into an R value, we do, what is it? 0.051. Okay, 1 divided by 0.051, and that gives us R19, basically. So that's going to be your minimum requirement for your above grade framed walls. You need R19 insulation. So with prescriptive requirements, you can't really do anything different than that. You have to at least meet that minimum. But there's also things like fenestrations, for example, your windows. They're saying that you need like a maximum U factor, maximum SHGC, and a maximum west-facing area. So it's not required in climate zone 1, but in climate zone 16, you need to have no more than 5% of all your windows on the west-facing wall. So let's say that your homeowner has like really large windows. They don't want to give up the look of their house, and they want more than 5% glazing on the west side of their house. Then that means that they could still comply with the building code, but they can't do it going with the prescriptive only approach. So that's an example of why performance modeling is so important. Prescriptive versus performance. So performance modeling is what I'm going to be walking through with you guys. And that's basically going through a whole house, and you can play with different components of the house and basically adjust different components and how the house uses energy to still comply with the building code, but not going on a basic list. Yeah, so you could follow all the prescriptive requirements for your climate zone, and then basically if you basically just fill out a form and say, this is how I'm going to follow the prescriptive compliance, and then you submit that to the building department. And no, you don't need to do energy modeling because they've done all the work for that climate zone, and they say, if you do this, this, and this, you're going to pass. So that's like the cheapest option, but it's also, it confines you to there's constraints for your building. And if you have somebody who like really cares about the design of their building and what it looks like, or yeah, just different aspects could change that. So that's why performance is important. Also, when you get into buildings that are going to be zero net energy or really high performance buildings, it's a no-brainer to go with the performance approach. And also, if you're doing rebate programs and you need to show that you're a certain percentage above the standard compliance for that building code cycle, you need to have the performance approach so that it'll give you that percentage value. Another good thing about energy modeling is you can get an assumption of how much energy it's going to consume throughout the year. You get the kilowatt hours per year. It could help you with solar array sizing. So that's another beneficial aspect of it. So there's new construction, and then there's also additions, alterations to an existing building. So those are two different types of modeling that you could do within the performance approach. So I think these are all just basics. They talk about the climate zones, the map of California, breaking down all the different climate zones. And it's also in the software too, so you don't have to identify it with the map. You can identify it by city in the software. So I was going to jump over to section 4 for the HVAC. So chapter 3 is all about the building envelope, which is the walls and the roof and the slab. And it breaks down all the mandatory requirements, which even if you're doing performance modeling, there's still mandatory minimums There's not a lot, but there's some. For example, I think wrapping pipes from domestic hot water, you have to insulate all the pipes. That's a new mandatory requirement in 2016 code. So whether you're doing prescriptive or performance, you still have to follow that. And this document breaks it down really nicely. So there's all the envelope details. Section 4 talks about the HVAC system, ventilation, and ductwork. There's some really good tables in here. See how good I am with the search function. The tables. So tables like this you'll find in this document that are really helpful. So if you're looking into like swapping out your heating equipment, like a furnace, for example, this is going to tell you your minimum heating efficiency that you need to hit for different types of systems. I like this one. Table 4-3 is the minimum heating efficiency for heat pumps. So this is a helpful page on page 187. And basically it breaks it down by like a package terminal heat pump, where everything's all in just one system, usually in the wall, like a hotel unit. And it gives you a minimum heating efficiency, and you could break it down to a COP, a coefficient of performance, based on your BTU rating and your efficiency values. So tables like this are really helpful as an energy modeler to come back and refer to. If you have any questions about, like, oh, I'm in this climate zone, what do I do for this? Or like, for example, with HVAC systems, you're not sure what the type of system is. These give really good breakdown of different capacities and efficiencies. Same for domestic hot water. And chapter 8 in this document is all about performance modeling. So if you want to be a pro, you would go through this whole document and check out all the fun pictures and understand how an efficient building works in California climates. So chapter 8 has single family buildings, multifamily buildings, basically giving you a really good approach on how to model these different types of units. Has subdivisions, and it also breaks down HVAC issues when you're doing modeling. So for example, Energy Pro and CBECC-RES are not very good at heat pumps. So they're, I think it's dominated by gas equipment in the building code. So when you're in the modeling software, you still can't really identify a really high efficiency heat pump or a really high efficiency heat pump water heater. I think the last cycle got a couple updates for NEA rated water heaters, but still there's some workarounds that you have to do for sure as an energy modeler to get these high efficiency equipment to actually perform in the model the way that they're supposed to. And when we do the advanced workshops, we'll be going through some more of these issues, but this is a document where they actually break down different possible problems that you could come into and how to approach them. And chapter 9 is talking about when you have an addition. So the example that we're going to go through together is going to be a new construction home where everything starts from the beginning. But other modeling approaches are for additions and alterations, which are It's an addition when you have an existing building and you want to add conditioned floor area to the building. That's the definition of an addition in the building code. So they have chapter 9 is a whole section on additions and how to comply with different changes that you do. So if you're also adding like an HVAC equipment to a new zone that's added on to a main house, you have to know how to comply with that. There's certain things you have to do by ducting the new system and changing the air handler or like the condenser unit outside. Just any possible change that you do to that house is all outlined in this document. And I think that's about it for this document. Pretty heavy. I've been mainly navigating through the bookmarks because it's so long and it takes a long time to load. But there are really nice details in here, like good pictures to give you kind of a sense of what they're talking about and best practices on how to install certain things. They also have really good sections on question and answers, so like most common questions that the Energy Commission gets or whoever's in charge of all this. They'll put these question and answers in this residential compliance manual to help you have a better understanding of what you're up against. And they have some equations to help you out also. So I am a big fan of this document. And then at the very end are the appendices where you have even more of those kind of table guides for different equipment. And it helps you to do the correct sizing of the equipment based on the conditioned floor area of your space. For example, you could do like HVAC sizing off of some of these tables by saying my house is like 1,800 square feet, and it'll tell you the BTU rating that you should use for a different type of system. So you guys have any questions on the compliance manual or anything about like an overview? What's that? Yeah, so that's table 150.1-A, and it's in the appendices. So it's probably not too far from it right now, but there we go. So page 480 is where you have this. Is this what you're talking about with all the climate zones? Yeah, definitely. So just starting out on a project, even if you are doing performance approach, just to have an understanding of how that climate zone works, I guess, you could use this to show you, for example, like if it's a really hot climate, when you look at the roof section, they're probably going to say to add a radiant barrier in the really hot climates. So like option A for attics, the radiant barrier is required in climate zone 2 through 15 and not required in climate zone 1 and 16. We're in climate zone 1, it's not very hot, so you don't need a radiant barrier to reflect the heat. And then it also gives a good indication of how much ceiling insulation you should have. Like climate zone 1 should have R38 ceiling insulation, and no radiant barrier is required. Depends on the climate zone, but it looks like there's a range of R30 to R38. So like climate zone 2 has R38 with a radiant barrier, climate zone 3 is R30 with a radiant barrier. So that's just an option. Yeah, so they have option A, attics, and then also option B, attics, and option C. And yeah, one of those is where you have the ducts in conditioned space in the attic. Another one is where you have an unvented attic, and then the other one is vented. And it breaks it down a lot more thoroughly in the standards. But first you would choose which type of attic you're going to have, and then you would go through that option to figure out your different requirements. But it looks like all across the board, if there's a radiant barrier required, you're doing R30 to R38 as minimum ceiling insulation. Any other questions, comments, breakthroughs? You got your minimum SEER efficiency ratings and HSPF and AFUE for space heating and cooling equipment. That's for gas systems. The annual fuel something efficiency. Basically, it's like between 0 and 100% for the efficiency. So I think mandatory federal minimums are like 68% efficient. And I think the most efficient that they have is like 98% efficient for space heating. Pretty much, yeah. That's the heating seasonal performance factor, I think. So yeah, that's mostly for heat pumps, where you'll have that value. SEER is for the cooling, and I think it's for electric or heat pump. I think, and the EAR rating also is another way to calculate the space cooling efficiency. But I'm not sure if it's heat pumps only or not. So the next section, I wanted to jump into our example and basically go through a set of project plans with you guys. We have an example plan set and also an energy model setup template. And Lynn, this is basically going to be the stuff that we went over. Spreadsheet. There's different tabs to go through all different components that we need to pull from the building plans and put into our energy model. So basically the process that we use is going into the plans, taking all the information that you're going to need from the building plans and putting it into the spreadsheet. Then when you use the software, all you have to do is look at the spreadsheet and you don't have to go through the building plans. This is really helpful, especially if you're doing large projects for multifamily. It keeps everything organized in one really clean and concise process. And then when you go back also in the future, everything is kind of laid out and you don't have to do your measurements again. It's just really easy to navigate in the future and also to do calculations. So basically we have a tab for the basic project information and then the orientation and the address of the house. Then we do all the fenestrations, so the windows and the doors. We go through and take the dimensions of everything and then add a symbol for each window or door that's unique to that dimension. Then on the dimensions tab, this is for the spaces of the house. This is to get the conditioned floor area. And then also adding the window codes that we developed on the previous tab to show whether the windows are on the front, left, back, or right wall. And then the floor plan tab kind of summarizes everything from the previous tab and brings it all together. And this is where we have the window codes, the floor area for the house, and then we also differentiate the exterior wall area and the interior wall areas. Because when you're dealing with energy modeling, you really only care about the walls that are touching the outside space. So we don't model, in residential, we don't model the interior spaces of a building. But in commercial buildings, you model everything separately. But with a house, you could basically treat the whole house as a box and just try and get the conditioned floor area the best you can. And then we track the perimeter of the house that's open to the outside, and the connecting walls and the ceiling height. So this is our floor plan that gets created into the model, and then there's another tab where we keep all the components that we pull from the building plans. And these are things like if the building plans show the studs for the walls are like 2x6 studs and they're spaced 24 inches apart, this is where we keep all of that information. I'll do a split screen and go through this building set with you guys. And while we're doing that, we're going to start our setup spreadsheet. And if you guys have Zoom on your computer, you're welcome to log into that link so you could view the screen a little closer, because I know it's a little tight right here. Just put yourselves on mute. All right, so who has not been through building plans before? Anyone? Yeah, okay. Well, here's our chance to go through it. Just like I went through the spreadsheet, I'll go through a set of building plans real briefly. This is a really good example of building plans. I liked this project, that's why I chose it. On the first page, usually you're going to have basically a breakdown of the project. So these are what the construction crew uses to build the actual house, and most of the stuff is for them and the building department, but we pull certain things off of it that we need. So the information that I like to pull from the first page is they have parcel data. So this is going to usually give a breakdown of your building area. So the architect will do this calculation for us. But since we do our own modeling based off of the spreadsheet that we're going to create and do our own dimensions, I like to just use this number as a reference for the conditioned floor area. So they give us the first floor is 1,250 square feet. The garage is 580 square feet. And then the second floor is 760 square feet. They also give us areas of the patio and the deck, but those are outside spaces. Those are not conditioned spaces, so we're not going to worry about those. Great question. The garage is considered an indirectly conditioned space. So we're going to model the garage, and basically we model the one wall that connects the house to the garage is going to be modeled as a partition wall, an interior partition wall. So the energy modeling software will understand that that wall is not actually getting the full climate from the outside of it. It's getting like a more controlled climate from the garage. So the modeling software will understand that when we select it as a garage, and it'll perform a little bit better because that's like a buffer zone for the house. I think that's everything from the first page. This is just the second page of information for the contractors. Yeah, they should have the project address. So once we find the project address, then when we're in the software, we could select the city and it'll tell us the climate zone. That should, okay, so the location of this is in Redwood Valley, California. And I have a really fun little PDF that I use. And it gives you all the climate zones in California. So if we go down to Redwood Valley, you can tell without going into the software. And it looks like it's climate zone 2. Yeah, Redwood Valley, Mendocino is climate zone 2. So if you wanted to get like a head start on it, you could look through the prescriptive things for climate zone 2 and see kind of like what we're looking at. But we will go through it in detail for the performance approach. So next on the plans, these are kind of like the grading. It'll show where the primary house is going to be. In this case, it was the previous house was burnt down in the wildfires. So this is going to be new construction on a plot where there was a previous house. So there might be some demolition in these plans, but this is basically just showing this is where the new house is going to be and the new garage. And this is like a really rough image, but this page will give you a good idea of the north arrow, so we could figure out the orientation of the whole house. And then going through the plans, you're usually going to have your floor plan, and they'll separate it out between the first floor on one sheet, like this is the first floor of the house and the garage. And the next sheet will have, oh, there's a little rendering, cool house. The next one's going to have the floor plan of the second story, showing that there's a deck over the garage. And then we have like a roof plan. It's kind of overhead what the roof is going to look like. And then there's elevations is what these are called. So these show the height of the building, and also what the face of each side of the house is going to look like. This is the east elevation, and this is what we're going to refer to check out where all the windows and doors are located, and also the dimensions of them. There's the east elevation, a west elevation, and the south side, and the north side. This is also where we'll find the ceiling heights for the building. And then these are basically sections. The building sections is another part of the building plans, and this is going to show you your insulation. So all these little squiggly lines around the building, those are your insulation values. And usually it'll say on the plans what the R value is, but you could also just measure it out and see with the scaling of the plans how thick they are. And then you'll be able to determine your R value. Next, they have buildings. These are like details. So they have different components that go into like the corners around the roof, and this is where they'll have really good details of what those pieces look like. And for example, they have R38 fiberglass insulation, and they also have a vapor barrier. And on the walls, they have R21 insulation with a vapor barrier. And then it just shows different layers of the wall that they're going to construct. These are usually good places to find the size of the studs they're going to be used in the walls and the roof. And their details are pretty spot on. This is a good set of building plans. Appreciate it. They have more details of different areas. It shows they have a radiant barrier. R21. Getting ahead of myself. I'm just going to go through these for now. Okay, so other sections. These are more details for the installers that aren't really, we're not going to worry about these too much. Weather stripping, and they do duct sizing, prescriptive duct sizing requirements. They have bathroom fan details with 110 CFM. House is going to be solar ready. They're just basic notes that they're saying about the house that weren't outlined in other areas. And it looks like this is the electrical plan, so it shows all the different strings of lights. In residential modeling, we don't really do much with lighting, so we don't have to do any modeling of how many lights are in each bedroom. Those are pretty much assumed in the software. Since it's all high efficacy lighting, they've done a pretty good job at generalizing that type of energy. But in commercial modeling, they have a lot more to do with lighting. Lighting is really important in commercial modeling because there's so many different types of spaces and how they use them. Here's more details on the electrical for lighting, but they also have details on the left for an exhaust fan with a humidity sensor. And those are the kind of details that I look for. And then this sheet is all windows and doors. So this is an awesome reference guide, so you don't have to go onto the elevations and measure every single window and door. So this one, if you zoom in really tight, it'll show each window's dimension. And then they give it their own code. So like this window, for example, is 10 feet wide. Okay, so that's probably a slider door. So 10 feet wide by 8 feet tall. And that's the way that we take the dimensions for windows. We do width first, and then we do height. So for example, with this window, if it's 10 feet wide and 8 feet tall, we would call that a 1080. So it's 10 for the width and then 80 for the height. And that's just your feet and inches. And that's how we'll break it down in the spreadsheet when we get to that point. And more door and window codes. And let's see, more zone or zoomed in details of the house are in the end that I'm not really going to focus on. But this does tell you the studs. So these sections on page 20 show that there's 2x studs, 2x4 or 2x6. But they have more details on that. Oh, and then at the end of the building plans, these are the compliance reports that we've already put together for them. So this is their submittal plan set for the building department, and they have to show that they've complied with the energy requirements for the building code. So they can show this, and this is the CF1R report. This is what your energy model is going to produce once you're complete with it. And it gives a breakdown of the whole building, all the inputs. And the best part is where it shows your percent improvement above the standard design. So this house is 21% better than a standard compliant house in California. And with, I think Sonoma Clean Power is the rebate program. and they're giving like $10,000 or $12,000 rebates for people who lost their homes in the wildfire and who are rebuilding. If they choose to go all electric, they'll give them these incentives. So all electric, Z&E, and they have to be 20% above standard. And so if they hit all three of those requirements, they could get $12,500 back from the utility company, which is pretty nice. I think with the cost estimates, it pretty much pays itself off, not including the solar, but I'm sure over time it's going to pay itself off. And I think that's about it for the building plans, everything that I would need from them. Do you guys have any questions about anything to do with building plans? No? Yeah, no problem. You guys ready to get started on the spreadsheet? A lot of fun. Okay, so some of the stuff we've already kind of gone over, but if you guys have the building plans up in front of you, we could kind of do a team approach to this and get some of these answered really quickly. So the date of the plans, the project address, the climate zone, and the utility territory. These are some of the things that I have for the project info tab on the spreadsheet. So the date of the plans is going to be in the bottom right-hand corner of usually any page, but the first page usually has the date stamp, or just any date that you could find on the bottom right. So here we have date created is 4/20/2018, and we're going to use that date. And the project address is Redwood Valley. On there. Yeah, the zip code after the city. I know you got the zip code in front of you. What you got? I totally have it. Oh, I found it. 95470. Sorry, I'm competitive. I'll try to pull back a little bit. Okay, so CBECC climate zone was climate zone 2 that we got from that document. And then the utility territory, this is in PG&E territory. Yeah, so that's the community choice. Yeah, that type of program. And Sonoma Clean Power works with PG&E because even though it's renewable energy, they're still sharing the grid. They're sharing their interconnectivity lines, and they're working with PG&E essentially. So it's mainly under PG&E. I'm pretty sure that's how that works. So we've got that down, and then the orientation of the house. For this, I'll go to, let's see this overhead view of the house and see if they have a north arrow on it. Okay, so on the sides, they have arrows that say north and south. So West. Where's the front door? Maybe the front door is on the second story? Okay, good call. Let's check that out. East elevation. West elevation. Huh. Sections. Yeah. It is pretty cool looking. I'm gonna cheat. I'm gonna go see what I did for their energy model and see which side I said was front. So I'm gonna use this to spot check our work. I'm gonna be using Energy Pro when we go into the software part of it. But if any of you want to use CBECC-RES, we could definitely do that also. Emily, you got any input on that? CBECC-RES is free, but yeah, I think Energy Pro is more user friendly, which is why I like to use it. CBECC-RES, since it is free, I would just go ahead and say they don't take as much care into making it user friendly. So some of the components you have to kind of go in and create your own HVAC system, create your own domestic hot water system, and there's like these dialog boxes that come up that need you to input a name or a specification along the way, and you're not really allowed to develop the building until you do it that way. I guess it's just preference, because I've been taught on this program and you do the same thing. You start with the domestic hot water and then you do the heat pump, but it's just more visual for me. So it's easier for me to navigate. And also they have really good libraries in Energy Pro. When you do create the domestic hot water or the HVAC system, you can open up a library and it'll give you an example of all these different types of products that you can import. So like if you wanted a heat pump, for example, you can select from all these different products that have been input into the software already. So we don't have to do as much work when we're going through and starting a model. Whereas in CBECC-RES, that's one of the biggest drawbacks that I find is that you have to create every single system each time you use the software. You can't save it into a library of products. Yeah, definitely. Yeah, it's all the same kind of science. You do the walls, the roof, the windows, the doors, your slab. Um, yeah, and then all your heating and cooling equipment. Try to think if there's anything else that's different. I think CBECC-RES allows you to do more identification with the layers of your wall construction. So if you were doing certain types of like gypsum board, plywood, if you did like special components to that and you wanted to get energy credits for it, CBECC-RES would allow you to kind of play with those and do, it would show the energy benefit of changing things on your wall layers. Whereas in Energy Pro, the wall layers are really only a functionality for non-residential modeling. So even though it shows you layers in Energy Pro, you're not allowed to really change them. The only thing that you can manipulate in the residential software in Energy Pro is showing that there's like added exterior insulation on a wall or added interior insulation, which is not just the cavity insulation where regular like fiberglass bat would go. It would also show like your continuous rigid foam board insulation or something on the outside. So those are still functional in either software, but there's just more, you could develop the wall a little bit. You could have more control over it in CBECC-RES. And I think that's kind of true for a lot of different aspects of CBECC-RES, since it is like an open source program. There's more functionality for certain things. Like it has more doors open essentially for you to click on and like manipulate, I think. But yeah, I think maybe essentially what I'm trying to say is that CBECC-RES, the developers left everything open for you to control. And in Energy Pro, the developers worked really hard to make things available for you to select. So you have, yeah, because Energy Pro also has it has other aspects that you can control more of than CBECC-RES. Like a lot of the tabs that are available in Energy Pro are not things that you can select in CBECC-RES. So yeah, this could be harder. Yeah, and I think a reason for that also is because with Energy Pro, I could use the same software and do a non-residential model and a residential model. So all the buttons that are available in the Energy Pro software, you kind of have to know which ones to navigate through to get through residential and to get through a commercial project. It's all available to you, but some things just aren't really clickable or they don't actually compute in the energy model because it's meant for a commercial space or something like that. Whereas CBECC-RES, it's all residential. CBECC-COM is all commercial, and it's a different software with its own functionality. So it's like more direct to that. So yeah, I think it all comes down to like user preference, though, because it all gives you the same report, gives you the same tools to analyze the data that gets printed out at the end. But with our thermal storage team, as you know, you can do a lot more with kind of controlling the inputs from behind the scenes with the open source software. So I think from the user standpoint, though, it's all the same, and I'm going to give Energy Pro my vote. I like it better. And you guys could totally download the Energy Pro 2016 software, Energy Pro version 7, and you don't have to have a license to use it, but you have to have a license to execute a calculation. So you could build a model yourself and save it, and then like you could send it to me, for example, and I can hit the calculate button. And like you could build your own model though. It's just you don't have the functionality of like seeing if it actually runs, which is one of the hardest things in building a model is like it actually calculating, making sure you didn't make any errors. So you guys think about it, let me know. And if you want to do a CBECC-RES tutorial, I'll have Emily do the CBECC expert. She could do a tutorial for that during our workshop session for another one. Great question though. So for now, we're going to get back to the spreadsheet. I think I assumed that this was the front with the staircase. Well, we don't necessarily need to know the front door. That's just how I indicate the front of the building. So when you do the orientation of the building, it's essentially you're walking out of the front door, and whatever direction you're facing is your orientation. So we're going to go ahead and call this side the front. Yeah. So the front would be facing west in this building. So if you take it on like a 360-degree circle, where north is 0, east is 90, and west would be 270 degrees. So that's what I'm going to say the orientation of the front door is 270. West. Okay. So now we go to the windows. And sometimes on the building plans, they'll give you a cheat sheet where if you go on the overhead floor plan view, they'll show you each window's code. That would be really cool if they had it. If we start with the front. Okay, so the front has this little symbol right here is W10. That's going to be this front window. On the front wall, it looks like we have W10, W11, W12, W13. That actually goes in here for the front wall of the first floor. And I'm just going to put them here. So it's W10, 11, 13. And I like to use their symbols if they have them, so everything matches with the spreadsheet and the building plans if I go back later and need to check it out what that means. So if you go on the fenestrations page of the building plans, we'll be able to decode what these mean and get the dimensions for them. So on page 15, these are D, so those are doors. Yeah, those are doors. So page 16 was the windows. So I'm going to have you guys help me out with these. I'll do the W10, but then you guys get ready for the 11 through 13 dimensions. It might be. So W10, are you kidding me? Okay, so W10 is 10 feet wide by 4 feet tall. And sometimes these will be broken up into 2 different windows because they do have a frame around each section. I think that's going to come up to be the, like, just use your best judgment. And if it comes back from the building department saying like, oh, you don't have those as like 2 windows, then you can go back and do it. But I'll do the easiest way at first. So I'll just say this is all 1 window. It's 10 feet wide by 4 feet tall. So on my W10, I'm going to go 1040. And we have a equation in here that's supposed to pull that into feet and inches. But it doesn't like to do the 10 sometimes. So 10 feet, 0 inches by 4 feet, 0 inches. And this calculates the area of that window. When we're using the software, the only thing that we need to use is that area for the window. You could even break it down into more simpler way to do performance, and you could say the whole front wall area. You don't even have to identify them as different windows, unless you have, what are they called? Your overhangs and your side fins for the windows. So if there's something that comes in an overhang and shades that window, and you want to take credit for it with the energy model, you're going to have to model that window separately and give it the overhang of, let's say, like 2 feet. And if it has a side fin to shade from like the west facing sun or something, you would want to take credit for that, so you have to model separately. But if there's like all a consistent overhang over everything, you can model it as one whole like area on a front wall. That's not how I like to model, but it's an option that still works if you want to simplify it. Do you guys have dimensions for W11? Mm-hmm. Is it the same? No. Okay. We'll call it a 2040. And then W12. We'll call that a 2680. And 13. 8040. Oh, that was the example, and I didn't put it in here though. But yeah, when we go through these, I think this is a project where they use a different symbol for every single unique window, but there are windows that are identical in size. So we're going to give those our own symbols. We're not going to double up on symbols in the spreadsheet just to make the model simpler. But yeah, I have 2040 for 11 and 8040 for 13. Okay, so then that's a great question. Basically, the dimension is kind of like my placeholder for 1040. It could be like 140. So you could have like 10 feet, 0 inches by 4 feet, 0, consistent. But I think that for this spreadsheet, like that's kind of on the user side, but when we input into the software, we just want to make sure that we compute the 10 feet by 4 feet. So it's, yeah, I'm not really sure how they do that in building plans, but if you guys want to go ahead and get the left wall, we can see if there's any, what windows are on there from the floor plan. We're on the first floor. Oh, wait, we were on the second floor. Yeah, okay. So let's stay on the second floor. We have, yeah, it's one of those elevated buildings where like the second floor, I think, is where the entrance is. Well, we could figure this out real quick. Yeah, second floor plan. We're gonna finish off the window and door codes on the exterior. Yeah, we could work around going clockwise. Yeah. So the west is the front. We'll go to the north side, and there's a D22. It says that there's a deck over the garage on this space, so that's going to be an exterior door that takes you outside of the deck. So we'll keep that door. That's a good question. I just assume that the circle, like, let's say east up here, for example, like, that's the east side of the building. That's what I'm assuming. And like the circle down here for west, like this is the west side of the building. Like I'm not looking at the triangle saying west is that way. I'm looking at it like, this is a great question. Let's go to the front. So here's going to be a good map. North is, so north is where the garage is. Yeah, don't pay attention to the arrows. That's weird. Okay, so we're still on the second floor. We have D22 and W09 on that left side. On the left wall, I'm going to add D22, W09. And then if you guys will help me get those codes, or sorry, the dimensions. Yeah, so D22 is a door, so I'll put that down here. And W09. Okay, so 3080. Mm-hmm. 2080. Okay. And I'm going to get complicated on that door 22. Do you see a window inside of that door? Okay. Great. Okay. It would have a little rectangle inside of the door that has like a slash through it to show that it's glass. Come up to those because we're going to have to model those as windows actually. You guys are doing great. We're going to get through this in no time. So the back wall on the second floor has a slider door, it looks like, so D21, W08, and D20. D21, W08, and what was the other one? D20? Okay, so I'm gonna make a note over here and say glass slider or glass folding door. We'll treat it as a glass slider. Okay, and what are the dimensions on it? Let's go with D21. Okay. Okay. So D20 and D21. We'll just call this like DF, door folding glass. I don't know. Because we're gonna just combine these two into one. So anything that's 10 feet wide, 8 feet tall, and glass folding is gonna be this code. Because in my mind, I think it's simpler. Okay, so then W08. Okay. You guys want to do the right wall? I'm the only one with plans up right now. Oh, gotcha. Whatever you want. But if we have a separate screen that's got, I guess we could use my screen. Okay. So the right wall is 7. And keep in mind, if there was something, let's say, on this part of the wall, that's still going to be a right-facing wall. So right-facing wall just has one window, it's 07. But just keep that in mind that anything that's facing that direction, it could be located anywhere on the building. Yeah, like a right window isn't just going to be on the far right side of the house. It could be facing right and it could be over here. Those are things to keep in mind. And that's why it's nice to like sweep across the building and go in like a circle so that you make sure you're not missing anything. 7 is on the right side. Exactly. Yeah, it calculates all of that for the sun and the climate that it's in. Yeah. Okay, we have one that's like that also. So we're going to go ahead and call this W. We'll just skip W7 because we already have that type. Not the cleanest way to do it, but I'm just going to do it that way. It's like here I created a new one. Yeah, we'll just use the same one. I'm trying to get unique windows and unique doors. No, basically when we go through and put it into the software, I'm going to use this tab. Well, I use the floor plan tab. So it's going to have all the window codes for each wall face. And then usually I'll do, if it's a huge model, I'll do a separate energy model just for the windows. And I'll just develop all the windows as their symbol. And then when I do the house model, I'll just kind of drag them in. So that's one way to do it that makes it a little quicker. But no, I'm not keeping track of the count of each, just where it's located on the wall and what the size is. Sure. When we go back later, we'll have an indication of why that's missing. Sure. And then we'll go to the first floor. And we'll do the same thing. Let's start with the front wall. And we have a W04, 03, C13, W02, W04. Okay. Okay, so it's W12. W04 equals W12. Okay. Okay. The one that does not have an opening on it is called a fixed window, and the one that does open is called operable, and those actually model a little bit differently. So let's keep track of that also. Thanks for reminding me. It's a different type, and all others are fixed. W07. Okay, so W07 differs from W08 because W07 is fixed. Oh, they're identical? Okay, cool. So it's still fixed? W07 and W08 are both fixed? Okay. So W08 is 6680. Okay. Thank you. I see. Oh yeah, 07 is 2080. Okay, good. Okay, so then the dimension of D13 cool. That's the door. Okay, so let's do DW13. This is the window to door 13. And I think it's 20% of the window or more. The window is 20% or more of the door space. Then you need to model it as a window. Yeah. Okay, so we'll say D13 is 2680. And we're just going to say it's the whole thing. So that's going to be that would work. Okay, so bear with me for a moment. I'm going to get the notes again. So that was W04, W03. Oh, so for all the dimensions of floor 2, I'm going to copy and same for floor 1. So I keep all of the equations in there. And the window code for the front wall. Yeah. Yeah, the front of floor 1, the window codes. No. Oh. Okay, so we have W01, W02, D13, W03, and W04. We have all those codes already in here. This is W01. That's in the garage, so actually we don't need to model that window. Leave it out because it's indirectly conditioned space. The only thing that we model from the garage is the connecting door to the house, if there is one. Okay, so on the right side, 06. I'm working backwards. And does anyone have a code for that one? all one fixed window. W06. Oh, gotcha. 6 W05 equals W06. And then the back wall, we have B01. B02, B03. So it's sliding, not folding. Okay. Okay. So it's D01 and then D02. D02. 30. Sounds like an accurate height for a door. So 3080. I'm sure if you zoom in, it's spaced out properly. Well, this one is one full door, and then it slides. So it's all glass pane. There's probably more of a frame on the one that slides. And this is probably just indicating that it's the back frame that accepts the slider. I see what you mean. It could be that there's no glass in that one, but I don't really know. Let's call it a 6080. Be safe. Does that seem better? Okay, so 6080 glass slider, and that was DO2. Glass sliding. Okay, so that equals 03. That's everything. And then we have garage doors, and that's going to be the last of them. Yeah. Let's see how I did this in the cheat sheet. So on the garage, I have 2 garage doors. I modeled the window also. I don't know if that was necessary, but yeah. So let's go ahead and get the doors for the garage. And that's going to be So DO5 and DO7. Really? Okay. Um, okay, so the garage on the left wall has 2 garage doors. Well, it's 10'8" for each wall, so it should be probably like 8 feet wide. DO5, DO7. Okay, so we're gonna call this G1. All right, on the left we have G1, G2, and those are our garage doors. And then our exterior door on the back side is a DO4. Yeah. And then we also have a WO1, we'll just add. And then W1. Beautiful. 60/30 fixed. Okay. So WO5. Oh, all right. Let me do some damage control really quick and go back with the windows. And while I do this, you guys can look at the elevation for the garage door. And I'll have Lynn show you how ruler scaled to the building plans. And this is going to be on elevation. So the north elevation on page 7 on the upper left-hand corner, it shows this garage doors. And then it gives you a scale on the bottom that says 1/4 inch in the plans is equal to 1 foot in reality. So the scaled engineer's ruler or architect's ruler, you just go to the 1/4 inch mark and you measure out how many 1/4 inch sections are in the garage door, and that gives you the feet and inch dimension. Yeah, so first, that's a great question. You're gonna have to calibrate your screen. So usually, like a door, for example, is a good place to start because they're usually 3 feet 0 inches wide. Yeah, so let's say, for example, we're on the left-hand side of the second floor. There's a WO9 and a D22. So WO9 is 2 feet wide by 8 feet tall. So if you want to use that window to calibrate, set your zoom to 100% and use the 1/4 inch scale and see how many feet it tells you that is for the width or the height, whichever you choose. And then if it's a little off, it'll usually be a little over or a little under. Resume your PDF. by like 1% at a time. And then you'll have it calibrated. Fail. I'm gonna be my TA next time. Yeah, you're good. I'm doing damage control over here. I did the window codes. I mixed them up on the Windows tab, but I didn't specify on the dimensions tab what my code was. Each quarter-inch tick mark on the ruler is a foot in real life. Whole number tick mark on the quarter-inch scale ruler in real life. Yeah. You guys write that down because I'm not done with this yet. Yeah, 8 feet 0 inches, I think, is pretty standard for the rest of the dimensions we have. Okay, so G1 and G2. What do we got for those? Or G1 equals G2. Nice. Okay. Yeah, it's a fun tool. Okay. Oh, okay. All right, so we have all of our windows and doors set up in the tab. that is a huge accomplishment. Good job, you guys. Way to have some teamwork. And the dimensions tab is going to be the next step. And we're at 6:53, so we're going to save that fun for next time. Did you guys expect to go fully submerged into an energy model? I hope I'm not turning you off, because this is, I know, right? This is about as submerged as you can get. I'm training you guys so you can help me with single family models. You know that, right? That's my scheme here. But yeah, I'm setting you guys up so you can understand how everything works, and it's all going to kind of come into place once we finish all the tabs. You're going to have a really solid understanding of where everything comes from in the plans and how it's relevant in the building energy model. And then, yeah, it's basically like a whole world to understand in the software. And so this is like all the little pieces that make it all come together. So with that, I'm going to say goodbye to everybody online. Thanks for joining. See you next time.